Hi everyone, welcome to Drawing Hub. This is Sanjana, and in this video we'll be starting with a new series of management of system software. This is module 1, Introduction to Software Engineering. So in this introduction to software engineering, in this video we'll be just doing the basics about what the introduction and things are. Then we'll dive deep into what different software processes are and all those things. Okay, professional software engineering. What is professional software engineering? So in that we have so many questions to learn in the professional software engineering part. So what then? Okay, first one, what is a software? Okay, what is a software? So there are a lot of computer programs, and those computer programs are associated with the documentation. So all those things, there we can say there are software products. So a software product is developed. It can be developed either for a particular customer or it can be developed for a general market. Okay, software, when a company when organization or whatever it is, they are producing a product, they're manufacturing a product, a software product, that can be either for a specific person or they'll make it with general format so that the general public can use. So there are two types of products, we've learned that. And so the computer programs and the associated documentation is software. Now, if we want to say it is a good software, what are its attributes of a good software? So what are the attributes? So we have certain attributes like the required functionality. If the customer have given certain functionality, those functionalities should be satisfied. The functionalities should be satisfied, the performance to the user. Okay, and it should be maintainable in case there is any damage or something. It should be maintainable, it should be dependable, the users should be able to depend on it, and of course it should be usable, because that is the reason why they are purchasing. So if a software have all these attributes, then we can say that it is a good software. Now we have learned what software is. Now, what is software engineering? Software engineering is an engineering discipline that is concerned with all aspects of software production. So, if anything that is related with software production, then that is related to software engineering. Then what are the fundamental software? You just have to go through these questions. It is not important. Now, what are the fundamental software engineering activities? Now, we have 4 software engineering activities which we'll be studying in deep about it. So just we'll go through the names right now. We have software specification, software development, software validation, and software evolution. We specify it, we develop it, then we test it, validate it, and then we evolve it. So these are the 4 fundamental software engineering activities. We have to learn more about it, and in detail, of course. Now, what is the difference between software engineering and computer science? So computer science means it focuses on theories and fundamental things. Okay, computer science. But software engineering means it is more related to practicalities of developing and delivering useful software. So it's more about practical things. Now, then what is the difference between? So that is software engineering and computer science. Now, what is the difference between software engineering and system engineering? System engineering is concerned with all aspects of computer-based system. That is, hardware will be there inside it, software will be there, process engineering, all those things will be there inside a system engineering. But software engineering is more concentrated on software engineering only, on the software part. It's more general towards that. But in system engineering, all these things will be coming. So it is a general process. Now, what are the key challenges facing software engineering? See, in this current era, we are having increasing diversity and the demands for reduced delivery times. The customers need the product to be delivered fast, and they also need a trustworthy. We have to develop a trustworthy software. So for all these are challenges for software engineers also. Okay. Now, what are the costs of software engineering? So around 60% of the software cost is related to the developmental cost. To develop the product, 60% will be gone, and the other rest 40% is gone for testing cost. Now, for custom software, if we are going for a custom software, evolution cost will also exceed the development cost. Okay. Now, what are the best software engineering techniques and methods? See, while all software projects have to be professionally managed and developed, different techniques are appropriate for different types. So, there are different techniques. We don't have a particular technique. Okay. Now, what differences has the web made to software engineering? The web has led to the availability of software services. Okay, we have software services, then the possibility of highly distributed service-based systems, web-based systems development has led to important advances in programming languages and software. So this is just some questions related to professional software engineering. Now coming to software products, we have two kinds of software products, generic product and customized or bespoke software products. Okay. So in generic product, okay, generic means from the word itself it is it's somewhat more generalized. So these are standalone systems that are produced by a development organization and sold on the open market to any customer who is able to buy them. So they are produced with standardized things and they are sold it in the they will be sold in the open market and any customer can buy them. So if we go for the examples, we have applications for mobile devices are examples, then software for PCs such as databases, word processors, drawing packages, project management tool. So all these things, anyone can use these. So this kind of software also includes vertical applications designed for a specific market, such as we can also use for library information systems, accounting systems, or systems for maintaining dental. Because these are all examples. So this is most generalized. Okay, but in customized or bespoke software, these are systems that are commissioned by and developed for a particular customer. So customized. So that is customized is for a particular customer. So a software contractor will design and implement the software especially for that particular customer. Now, example of this type of software means electronic devices, control systems for electronic devices, systems written to support a particular business process, and air traffic control system. So these are all customized. It is generated for that particular person or that particular customer. That is the different types of software products, generic and customized, two types. Okay, then we have software engineering. What is software engineering? This is the definition for software engineering. Okay, software engineering is an engineering discipline that is concerned with all aspects of software production. Okay, software engineering, this we have mentioned before, it is an engineering discipline that is concerned with all aspects of software production from the early stages of system specification through to maintaining the system after it has gone into use. Okay, so first of all, it is an engineering discipline. Second, it will include, the software engineering will include all the aspects of software production. That is, first we have to, in the activities, we have to study about specification. So right from the system specification, till the end to maintaining the system, all these are different stages in software engineering and the software production. So during all these stages, it is a discipline. So it is an engineering discipline. Software engineering is an engineering discipline that is concerned with all aspects of software production from the early stages of system specification through to maintaining the system after it has gone into use. So in this definition, I have marked two sentences, two phrases to be more precise: engineering discipline and aspects of software production, if you have seen. So what is engineering discipline? Okay, engineers make things work. That is, from the theories, from the methods, the tools, from all where they are appropriate, we use them selectively and then we try to discover solutions to problem. Even when there will not be any applicable theories and methods, but we will make things work. So engineers also recognize that they must work with, engineers have lots of constraints, like there will be organizational constraints, there will be financial constraints. So they must look for the solutions within these constraints and they should work. So that is engineering discipline. That is what they mean by engineering discipline. Then all aspects of software production means software engineering, it is not just concerned with the technical processes of software development. It is not just about the technical things. It includes activities like software project management, the development of tools, the development of methods, theories to support software development. So all these things should come together. That is what they meant by all aspects of software production, because software production is not just about the technical thing or many other things like management, development of tools, methods and theories. All these things should be brought together. So when these two phrases come, so these two are the two very important phrases which we cannot avoid in the definition of software engineering, which we should mention. Software engineering means engineering discipline should be there, and also all aspects of software production. Software engineering it is an engineering discipline that is concerned with all aspects of software production, from the early stages of system specification through to maintaining the system after it has gone into use. Now coming to the attributes of software engineering, we have 4 attributes as of now, or you can study it as 5 also. Maintainability, dependability, security, efficiency and acceptability. Maintainability, first thing. So whenever an engineer writes, see, I am an engineer, you can think that you are an engineer. Whenever we are writing an engineer, whenever we are writing a software, it should be written in such a way that it can evolve to meet the changing needs of customer, because the needs always change, the needs of the customers always change, and we should constantly update our software. Therefore, this maintainability is a very critical attribute, because software change is inevitable. We cannot, it is an inevitable requirement, because we do not know when the software have to be changed, especially in a changing business environment. So, maintainability is a very critical attribute, and whenever an engineer writes a software, it should be written in such a way that it can evolve to meet the changing needs of customer. That is our first essential attribute, maintainability. Second one is dependability. Dependability means software dependability includes a range of characteristics. See, the customer should be able to should be dependable on the software. The software should be dependable. That is, there will be a lot of characteristics like reliability, security, safety and all. So, dependable software should not cause physical or economic damage in the event of a system failure. In case there is a system failure, so when a customer depends on that, a customer will of course depend on the software. But if there is any system failure, that should not cause any physical or economic damage to the customer. Okay, so that is dependability. Software dependability includes a range of characteristics including reliability, security and safety. So inside that security is coming, maybe that is the reason why they have included as a single point. Okay, again security means there are a lot of malicious users out there, and these malicious users should not be able to access, because once they get to access the system, they will be able to damage the system also. So there is malicious users should not be able to access or damage the system. That is why dependability and security they have written together. You can write it as different attributes also. Then comes efficiency. Efficiency, software should not make, see, we have resources, but we do not have a lot of resources, right? So these resources should not be used in a wasteful manner. Software should not make wasteful use of system resources such as memory and processor cycles. So these are our resources. In terms of software, memory and processor cycles are our resources. So efficiency therefore includes, okay, responsiveness, processing time, memory utilization, so many things are there inside. So that is about efficiency. Then comes the acceptability. Acceptability means software must be acceptable to the type of users for which it is designed. Software is designed for a particular person, and the software should be acceptable to that user. This means that it should be understandable, it should be usable, it should be compatible with the other systems that they use. That is acceptability. Okay, these are the 4 different essential attributes of software engineering: maintainability, dependability, security, efficiency and acceptability. Now coming to the importance of software engineering. So software engineering is important for 2 different reasons. First one, more and more individuals and society rely on the advanced software system. So right now, individuals and society are relying on advanced software systems. And we need to be able to produce reliable and trustworthy systems economically and quickly. So we have to be fast with it, and it should be reliable, and it should be trustworthy systems because it is being advanced. The technology is getting more advanced. Also, this software engineering is important because when we look in the long run, it is cheaper. So to use software engineering methods and techniques for professional software systems rather than just write program as a personal programming project. Now, failure to use software engineering methods lead to higher cost for test quality assurance and long-term maintenance. So so all these reasons specify why or emphasize why software engineering is important. Then comes the software process activity in a short manner, where it says it is a systematic approach that is used in software engineering. It's called a software process. And software process, it is a sequence of activities, and we're having 4 fundamental activities inside that. So this will lead to the production of a software product. So first one is software specification. I have already mentioned the names inside, okay, before in the question section. Software specification, software development, then software validation, then we have software evaluation. Okay, these are just the names. Now, software specification means where customers and engineers define the software that is to be produced and the constraints on its operation. Okay, customers and engineers define the software that is to be produced and the constraints on its operation. So the customers will say, okay, from the customer, the engineers will, okay, get the details, okay, what all things does the product need, what are the constraints of it, they'll get all those details. Then second stage is development, where the software will be designed, coding and all those things, programming and all those things. Then software validation. So once we are done with all those things, now we need to check, we need to test if everything is okay. So we have to ensure if whatever the customer requests, is it available, is it okay. So software validation. Then software evaluation means everything is done, and we have submitted, or we have given the product to the customer, and then we say, okay, maybe there is some change, or according to the market requirements, or according to the customers changing, you know, there might be any changes in the customer's requirement at that particular time. So based on that, again, we can evolve the software. So these are the 4 activities: software specification, software development, software validation, and software evaluation. Okay, this is just not even a brief. I've just mentioned what it is. We have to study it in very detail with the diagrams also. So now, general issues that affect the software. Okay, now what are the issues? First one is heterogeneity. What is this heterogeneity? Increasingly, systems are required to operate as distributed systems across networks that include different types of computer and mobile devices. See, now these are the issues of software. So as of now, these systems, they are all distributed in different networks, and they have to be worked in different types of computer, different types of mobile devices, and also this is an issue of the software. Why? Because a particular example, a particular software might be developed for one particular system if it is customized. So at that time, there might use might arise in these cases. Then business and social change. Okay, change, we know it is an issue always. Businesses and society are changing incredibly quickly because the emerging economy, new technologies become available. So we have to keep on changing, we have to keep on evolution. Then the evolution process, that has to be a continuous one. It does not stop anywhere. So they need to be able to change their existing software and to rapidly develop the new software. So this is something different. And now that is another issue. And then comes security and trust. So this software, it's kind of intertwined with all the aspects of our life. So that we have to if there is any issue that we trust the software, and if some malicious users just get inside, and security and trust is of course different, because security is when someone tries to get inside. It's about protection. Okay, both are related to protection. So, as software is intertwined with all aspects of it, because trust is developed if we get proper security, right? Then comes scale. So scale means the software in different, it can be in a smaller scale or it can be larger scale. So wide range of scale. That is a smaller scale means embedded systems, it is portable or in the wearable devices, and we have the large scale, that is internet scale or the cloud based systems that serve a global community. So these are all issues which the software faces. Okay, heterogeneity, business and social chain, security and trust, and scale. Then comes software engineering ethics. Okay, we know what ethics is. So software engineering ethics means we know that, without saying only, we know that normal standards of honesty and integrity should be maintained. So whatever skills we have, you're an engineer, with whatever skills we have, whatever abilities we have, we should not behave in a dishonest way or in a way that will bring disrepute to the software engineering profession. But there are areas where standards of acceptable behaviors are, see, not everything is there in the law. So this is something more of a professional responsibility than the law. And some of these are, first one, we have confidentiality. What is confidentiality? So keeping things in a confidential manner. It's not about being secretive. Usually, we should respect the confidentiality, even if it's of the employers or even if it's of the client. So, we may not have any sort of formal agreement or something. We might not have signed any confidential agreement, but still, then there is something called confidentiality which goes without saying. And then comes competence. Competence means we should not misrepresent our level of competence. That is, we should not knowingly accept the work that is outside your competence. So we have a level and we should stand at that. Then intellectual property rights, IPR. Intellectual property right means we should be aware of there will be a lot of local laws about the intellectual property right, like it can be patents, copyrights and all those things, and we should always be careful to ensure that the employers and the clients intellectual property is protected. That is intellectual property right. Then comes computer misuse. Computer misuse means we should not use our technical skills to misuse other people's computer. See, it can be trivial to extremely serious. So in this example, trivial means say for example you go and play game in one of your employer's system. So that is a trivial. Okay, we can say that's something small, but still that is computer misuse. And extremely serious means if you just disseminate of viruses or other malware in some other system. So that is extremely serious. So this is just example. Now, these are the software engineering ethics that you should be following. We have confidentiality, competence, intellectual property rights, and computer misuse. Then in the next video, we will be studying about software process models. We have different types of software process models and all. We'll be learning that in the next video. So till then, bye-bye.